Hey, this is Kumar, and today's topic is why LLMs cannot do scientific experimentation. Imagine a world where every lab has a scientist that never sleeps, never eats, and can answer any question instantly. Sounds like science fiction, right? But with large language models, LLMs like GPT-4 and beyond, people are asking, do we even need scientists anymore? Here's the truth. LLMs are incredibly powerful tools, but they cannot and they should not replace the process of scientific experimentation. In this video, I'm going to break down exactly why that is, from their architecture to the philosophy of science, so by the end, you'll know exactly where the hype stops and the hard truth begins. Let's set the stage. First, let's define our terms. An LLM is a large language model, essentially an advanced text prediction engine trained on massive amounts of human writing. Scientific experimentation, on the other hand, is a structured process. Formulate a hypothesis, design a controlled test, gather observations, measure results, and confirm reproducibility. At first glance, they seem compatible. Science is documented in text, and LLMs understand text, but understanding text is not the same as understanding the underlying reality. Reason number one, LLMs lack grounded causality. Scientific experiments are grounded in the cause and effect structure of the physical world. LLMs, on the other hand, are grounded in statistical relationships between words in their training data. They don't know why gravity pulls objects down. They just know that in most human text, gravity is followed by pulls objects toward Earth. Ask an LLM to predict the boiling point of a hypothetical chemical, and it can give you a plausible sounding number. But the number is based on patterns in text, not actual measurements or calculations from physical principles. Without access to real-world data collection or reasoning over causal mechanisms, LLMs can confidently give you something that sounds right, but is physically wrong. And in science, that's dangerous. Reason number two, no empirical reality. Science is about testing reality. It's about going into the lab, running an experiment, collecting data, and analyzing it. LLMs can't run a chemical reaction. They can't measure a voltage. They can't record a temperature. At best, they can simulate the language of results. But simulated results are not the same as empirical ones. It's like describing the taste of a fruit you've never eaten by reading restaurant reviews. You might get the adjectives right, but you have no direct sensory experience. Because they have no physical interaction with the world, LLM outputs are always secondhand. They're derivative. And if you treat them as primary evidence, you risk compounding errors. Reason three, inability to handle novel phenomena. Scientific breakthroughs often happen at the frontier, where little or no prior data exists. LLMs are trained entirely on past data. If something has never been described before, they can't truly discover it, only guess based on analogies to what already exists. When CRISPR gene editing was first discovered, it wasn't in any textbook. It came from physical experiments. An LLM trained before that date could not have invented the method. At best, it could have made plausible but unfounded speculation. Novelty is a blind spot for LLMs. They're built for interpolation, not true exploration. Reason number four, reproducibility and verification issues. In science, reproducibility is king. If you can't reproduce the result, it's not valid science. LLM outputs are not reproducible in that sense. Run the same prompt twice, and you might get different answers, even for numbers. And when they hallucinate, producing confident but false information, it's nearly impossible to trace the exact source. In a lab, every measurement has metadata, provenance, and method logs. In an LLM, the source is billions of parameters trained on billions of words, a black box. Without clear traceability, you can't validate results in a scientific way. Reason number five, correlation is not causation. LLMs are correlation engines. They excel at finding statistical relationships, but correlation does not mean causation. Given enough climate articles, an LLM might tell you that there's a strong link between sunspot activity and economic recessions because that pattern appears in niche publications. Without any valid causal explanation, scientific reasoning demands that correlations be filtered through theory, evidence, and domain expertise. That's something far beyond pattern matching text. Now let's talk about what LLMs can do in science. Right? It doesn't mean that LLMs are useless in science, far from it. They can be powerful assistants for reviewing literature and summarizing findings, brainstorming hypotheses, suggesting possible experiment designs for humans to vet, automating documentation and drafting reports. The key is to treat them as advisors, not experimenters. They can help scientists move faster, but they cannot replace the scientific method itself. All right, wrapping it up. LLMs and scientific experimentation are not rivals. They're different categories of tools. Science operates in messy, unpredictable physical world. LLMs operate in the structured statistical world of language. Confusing the two risks bad science, wasted resources, and false confidence in untested claims. So, the takeaway is simple. LLMs can help science, but they cannot be science. If you're in research, use them to amplify your thinking, but never as a substitute for the experiments that move knowledge forward. If you found this breakdown useful, like the video, share it, and let me know if you have any other questions. We'll be happy to have a chat. Thank you.